Hello, welcome back to More Fun Fixing It. It's another repair episode. This one is the second of 5 C64 silver labels, and somebody commented about these being plastic labels. They are definitely plastic, yeah. Are some of the other ones metal? I thought they were all plastic. I can't imagine Commodore spending money on metal badges. This one, let's have a quick look on the other side. Has a serial number of WGB, so West Germany, 19245. Reasonably early. And this isn't a fake silver label. This one has got a genuine early-ish board inside it. So the case is in pretty good condition. All of the clips are intact. They have got stress showing on them though, so they're not going to last forever. And when I give these back to Paul, I'm actually not going to put them back together properly. I'm just going to leave them with the screws out and everything, and I'm going to let Paul put them back together because I don't want to break these ones. Anyway, the case is in reasonable condition. Physically, there's no scuffs or holes in it. No one's been playing darts with this one. It just needs a good clean and a retro bright if that's your thing. But yeah, that's looking okay. Keyboard is in good condition. The lettering has yellowed slightly, but a lot of that will clean off. Looks good. So yeah, let's put this one aside. Oh, yeah, let's put this one aside. This video is sponsored by PCBWay. A little behind the scenes story from the workshop. I was recently sent by my friend Martin a C64 mini PCB, and I thought it would be fun to drop it into a full-size bread bin case. The only problem was the keyboard. How do you connect an original Commodore 64 keyboard to a modern mini board? After a bit of digging, I found that somebody had already solved it, and they'd uploaded the design to PCBWay's shared projects library. There it was, a ready-to-order PCB that converts a real C64 keyboard to USB using a Pi Pico. Exactly what I needed. No extra work from me. And honestly, it couldn't have been easier. A few clicks, ordered a batch of 10, job done. The price was super low, and even with the budget postage option, the boards will still arrive well before I even start the modification. That's what I love about PCBWay. Whether you're designing your own boards or grabbing something clever from the shared projects library, it's incredibly quick to go from idea to actual hardware in your hands. So if you've got a retro project, an adapter board, or a completely new design in mind, check out PCBWay, and don't forget to explore the shared project section. You never know what brilliant solution someone has already made. On with the show! It has the RF shield still in place. This is quite heavily corroded, and the computer inside is in very poor condition. Well, I mean, the condition is fine, but it is really dirty. This one's going to need a wash. But the good thing is all of the chips are in sockets and nothing looks to have leaked in terms of capacitors in this one. So, oh no, this one has got capacitor leakage. Damn it. Right, so I picked this one out thinking it was one of the ones without capacitor leakage and I was going to give myself an easier ride. But no, this one has leaked all over this chip and it's in really bad condition. So I'll take it out of the case and then give you a closer look. I think in this one's case, I think that's going to have to go. I'll send it with the machine, but I'm not going to install it back inside because it's in horrible condition and I'm not going to be able to clean that. Right, this is what happens when we turn this one on. Nothing. Not a sausage. Do we have any continuity through the fuse? Yeah, the fuse is good. What about voltages? The 12 volts is there. 5 volts is a bit more tricky to get to. 5 volts is there. Should have 5 volts here as well. And should have some around 10 volts AC here. Yep. So it's got all the voltages. But I think the problem is down here. So let's show you that under the microscope. So that capacitor there has leaked all over this side of these chips, or that chip. And that capacitor there has leaked all over this side of the chip. So what is that? 74 LS629. And I've got a parts board here with that chip intact, so I can pop that out of there and put it in here as a replacement. Yeah, that's plan A, but I'm also going to have to take this chip out and make sure there's no trace damage underneath that chip. And I'm going to have to recap at least those two caps. These all look okay. The pads are reasonably shiny on these. I can't see anything crusty under these ones. So I'm not going to touch these dark blue caps, but these black ones inside the inside the VIC2 can have basically let go. So I think before I try and do any diagnosing, I'm going to physically fix it by taking this chip out, repairing any damaged parts underneath, any damaged traces, replace these caps, replace anything else that's damaged, put a socket in there, put a new chip in there, then switch it on and see what happens. I can see the damage, so I'm not going to waste time by trying to diagnose it. Well, what have we got going on the back here? Nothing on the back looks to have been reworked, which is a good sign. A little bit of damage here. There's a little bit of corrosion there. I don't think it's actually done anything serious. Yeah, I think I'm happy to go with that plan of action. And once we've got that sorted, I can then look at the rest of this and get this. Maybe I should wash this first. Nah, let's wash it later. It'll be fine. It'll be fine. Okay, for this desoldering event, I'm going to be using this thing. This is a Gauzy S993A, and it's going to be part of a future video where I round up all the different desoldering stations that I've gathered to myself in recent times. So yeah, you've got that to look forward to. Let's turn that down a bit. Sounds quite good. Yeah, solder just gone everywhere. Don't like that. Right, before I do that, I'm just going to reflow the pins on this chip. All right, that's had a nice amount of time to warm up. Let's see how it does. It's angry. Whoa. Now that is actually really impressive. It feels cheap, but that pump feels like it's really doing a good job. And what's really impressive is that on something like this, I would expect that the solder on the other side would flow nice and easily and be sucked out. But the solder on this side that has been corroded and has suffered from damage should stop that from actually just coming out. And that has just fallen out of the board. I am absolutely stunned and amazed. That's done a really good job. I might have to change my opinion on that one a little bit because I had a bit of a preformed opinion. Okay, having a look at what we've got before cleaning. Definitely some signs of crustiness and damage. That's not a problem there. It's only under there that looks okay. Luckily, there's no small traces like this one here. Should be okay. If anything like that had gone underneath here, I'd have been concerned. Oh, there are two traces actually. I'm talking nonsense again. Yeah, I might have to, because there's dark spots on there that aren't. Are they on the surface though? Yeah, let's just take that solder mask off and replace it. Right, let's give it a clean first with an old toothbrush and some isopropyl. Should I use vinegar first? I'm going to wash this, so I might as well use some vinegar. I can use, I've got a big tub, could I use that? Of citric acid, but vinegar's just as good. It's not reacting too much. I need to take those caps out as well. Caps don't want to move. There's one. Oh, that one's coming out all by itself. Right, so we've got two caps out as well. Let's have a look at what's going on under those, because that's where all the damage was. There's one. Yeah, that's where the most of the leaking has occurred and caused any corrosion. So I just need to scratch all of that back. It looks like there's no pad damage. I have to be careful of that trace, make sure that that's okay. Because it goes underneath this solder mask and it eats the copper underneath the solder mask. As you saw in the last video, that it just weakened to the point where it just went. It just gave up. This feels pitted and horrible. And that one there is in a similar state, so just all these traces look, yeah, don't look good. That one there. I can't leave them like that because there is electrolytic fluid still sitting in underneath that solder mask in those dark spots. That's what's happened there. So if I leave it, I risk it corroding in the future. Right, I'm just going to give that a squirt of isopropyl just to try and neutralise this vinegar that I've put in there for now. And let's take that Vic 2 out as well. Yeah. Give this a quick once over with some braid. All right, now we just need to start cleaning it up. It's all corroded. There's a dark patch there. That's, I think that's where it's corroded through. I think that's bored on the other side of that. There's another one there, but again, that's probably where it's corroded through most of the way. I think we've mostly been lucky. Yeah, okay. Don't think I need to take anything else out. Oh, there's a bit more down here. Oh yeah, there's a bit, loads more. I've just lifted that, is that an inductor, up in the air, and there it is, so that I can get to this trace underneath it. In fact, that trace as well. This is always the fear when you are repairing anything that's been damaged with corrosive substances, is what about the hidden bits when it's underneath chips and other components? And you might fix it on that day, but if it's left, it might come back and haunt you in years to come. That's okay. It's okay. It's just dirt. Or maybe not. So normally I would go over this now with a fiberglass pen, but I've misplaced it and I have no idea where it is, so I can't do that. So I'm just going to clean it up best I can. I've got a hand drill here. I'm just going to go through all of these wires with, just to clean them out. I'm going to just try flowing a little bit of solder onto here so I can clear this one out. It's not going to want to take it. No. Excellent, that one of them's cleared. See if I can get the other one. Excellent. It's not very pretty around there, but the wires are intact. I just need to test if they are connected, or if everything's connected really. So that's the next job. Where's that go to? It goes straight through. That's good. That's connected. Right, I think the thing to do now is just to check side to side. Right, so one last look. Missed a bit around here. Right, just as an experiment. Yeah. See, the bits that aren't clean don't like to take the solder. Right, I'm not happy with that bit. I'm not happy with that bit. I think that they are damaged. Whilst there's a load of flux in there, I'm just going to go over it with a braid. Just to take off any excess. So all I'm trying to do here is remove anything that might carry on corroding. I'm fairly sure I've got all of it. This bit here is just gone, so there's me scratching away at that is just not really doing very much apart from digging into the board. These bits here are now copper, I think. Still might have to fix this. So I don't think with this trace is meant to be this heavy for a reason. This is probably ground, is it, or something? Let's have a look. Yeah, that's ground, and that needs to be as thick as it is for a reason. It needs to be able to take various amounts of current without getting hot and vaporizing. I'd like that one to have filled up, but it hasn't. I think the next thing I'm going to do is to pop all these chips out, find a safe place for them where they're not going to get all their legs bent up, get this board washed and cleaned down now that I've got all of the corrosion off of it, and then see where we are at that point. I'm probably going to take that socket out as well and put a better dual wipe socket in here. But yeah, get all of this crud off and then we'll see where we are. I think that's the thing to do. So the next time you see this, it's going to be clean. I'll have removed all of the solder here, and then we're going to start painting solder resist on there and putting everything back. How does that sound? Fair enough? Okay, it looks a bit different now, doesn't it? I've cleaned it. I didn't wash it in like a sink or anything like that, just purely because it wasn't very convenient to me at the time. And if I wanted to do that, I'd probably need to leave it overnight before I could work on it again. Still a bit of grottiness on the bottom here. But what I did was actually I used Windex, quite a lot of Windex with a cloth on the workbench, squirting it and just draining it down just to rinse off what was on there, and then followed that up with a similar bath with isopropyl alcohol, agitating it with brushes and the like as I went. And that seems to have worked really well. My brushes are all grotty now. Anyway, that's all done. The only thing really left to do now is to paint up these bare traces. All of this needs to be covered. Now I've taken a picture when I come to put all of this back together, I'm still aware that this bit here is mostly eaten through. So everything there is gone, and it's only at the sides that it's hanging on. So I'm not going to put anything on this side because the socket won't sit flush if I put anything here, and this cap won't sit flush. So I'll install the cap. On the other side, I'll run a budge wire between these two, or probably a component leg, because hopefully there's nothing running this way. But yeah, I'll run something between these two. What is that? How many pins is this? this thing got 1, 2, 3, 4, 5, 6, 7, 8. So that is pin 14 and the negative of that cap, just to make that earth a little bit stronger. Now, I just need to paint it. Start over here. Okay, leave that for a bit and let it cure. Right, have a quick look. Make sure it's cured. Yep, it's not incredibly pretty, but it won't deteriorate anymore. So I need to put a socket in there and then start putting everything back. You'll notice that there aren't any chips in here. I took them all out and I tested all of them, and the only one that's faulty is the SID, which is disappointing. And it's so faulty, it completely stopped the computer from booting. And that cap's just actually come away from there. I'm just going to resolder that. There you go. Just came away with by just me bending it up. Okay, so that's done. Let's get some new caps in there and a new socket in there. I will take this one. Actually, yeah, let's take that out first. Let's take this socket out of here first, and then put everything back all at once. Still using the gougie. That's just falling out again. I'm not. I'm so impressed how the performance of this desoldering station is stunningly good. I've got a bit of a decision to make, because I thought this was going to be cheap and nasty. And it's not cheap and nasty, it's cheap and good. That's good. That's just fallen out. It does occasionally squirt solder back up through the holes though. That pump is so vicious that it's ejecting the solder rather than sucking it after a certain point. Anyway, that's for another video. Let's get a socket in there and a socket in there and then see if this works. A 40 pin and a 16 pin. Got no center brace in this one. How unusual. Look at how that's affecting the board when I'm heating it. That green changes colour. That. And then it fades back down. It's quite interesting. Okay, looks better after a nano sponge wipe. Okay, couple of bits to replace that inductor and the caps. Now this time the caps are the right footprint. How unusual. And they're definitely the right size to go in here. Here we go. This is the chip that I took out of this position here. Actually, oh no, we can worry about that in a minute. Which is a 74LS629. Now, I, being a beginner of electronics and electronic theory, assumed that all logic chips, 74 series logic chips, there are other series logic chips as well, but all 74 series logic chips would be the same sort of thing, logic gates. They would perform logic functions. This is not a logic gate. This is a voltage controlled oscillator. In fact, it's 2 voltage controlled oscillators inside there. And this is a chip that's used in things like the ZX81 and the ZX80 to help generate the video signal, the clock for the video, or parts of the video signal. And you can tune this, you can tune the frequency it oscillates at. How clever is that? So this isn't a logic chip. So when I plugged it into my chip tester, it didn't work. When I plugged it into the T48 XGECU programmer and tested it that way, it didn't work. It wasn't recognized by anything on there. And when I plugged it into the Retro Chip Tester Pro, I couldn't find it in there either. It might actually be in there, but it's not under 74 series logic. So I can't test this that I know of. There might be a way, but I haven't. You know, it will take me time to find out how to test it. And an easier way to test this is to put it in and see if it works, or put it in another board and see if it works in that one. But I have got some other chips over here. These are 74 LS629s to try, including a brand new one. One of these is, yeah, this one's brand new. In fact, that's not an LS, that's a HCT, I think. No, it's an LS. Interesting. Shall we try it? See what happens. First thing I need to do is put all of these other chips back. Starting with the VIC-2, which needs a clean. Oh, that's a satisfying crunch as that pops into its socket. You know, everything else on this board seems to be working. Like I said, apart from the SID. So I'm just going to pop all these straight back in. The first thing I'm going to do, because these are all the original sockets all the rest of these are the original sockets. That's the only one I've changed. I need to spray these because they are crunchy and dirty, and they're not taking the chip very well. So give them a coating of contact cleaner to give them every chance of working. And they are all, I think, yeah, they're all single wipe as well. That was all right. That's all the ROMs, CPU. This lovely PLA from Singapore, C64A, 93459 DC from 82, 31st week of 82. Give this a little dry. Chips just went everywhere. Okay, and put it in a case. Ew, look at that. There's a brief clean out. That should just house it for now. I don't want to clean it. I don't like cleaning computers. Okay, what does this do? Original 74 LS629. Still nothing. Oh, we haven't got the original 74 LS629 in yet. Okay, that's in. Anything? Nothing. Okay, before we investigate, I'm just going to try putting another one in there. Let's put that new one in. Ah. Okay, well, that's kind of definitive, really, isn't it? Okay, so I've put one of the old stock 74 LS629s in there, and you can see working perfectly. I've still got to put the test harness on this and make sure everything is working and do something about the SID. Not sure what to do. We'll just probably do the best we can with that. But yeah, this part of the circuit is something I've now learned a bit more about. And it's basically what this does is this provides the clock for the color signal for PAL or NTSC, or PAL in this one's case. Basically, all of these chips working together with the crystal lock a signal, the frequency of this color carrier, to the exact signal that it wants to be, and this allows them to, or allows the board to adjust this frequency up or down using the crystal as a reference to prevent things drifting out. It's an ingenious use of a chip, really clever. But I don't pretend to understand. I'm not going to try to explain it to you because I don't know enough about it. I just know that if that's not working, you're not going to get any video signal at all. And it was obvious, really, what the problem was with this one, with these two caps on either side leaking all over it, all over the original one. The corrosive fluids has worked its way inside this package and killed this chip. So that's the end of that one. Right, let's attach a test harness, put the diagnostics back in, make sure this is fully working. I just want to know if everything's working. Oh, controller port bad. Oh yeah, of course, the SID's not in there. Let's get a test SID. This one doesn't have the full range of sound, but it does pass tests. Okay, so let's try the full RAM test. Make sure that everything's working as it should. That's working exactly as it should. No problems with this board now. Before I take that out, I'm going to test the keyboard, which I assume, considering the condition of the inside of the machine, that the keyboard might not work. It's probably going to need stripping down and cleaning inside, but I'm probably not going to subject you to that, but you'll get to see the testing part of it. That could be okay. It doesn't look too grotty on top. All right, I'm going to go straight for the one that always fails, and it's good. The keyboard's perfect. Wow, I did not expect that. Okay, so this is a bit more valuable than the last one with this KU type board inside it. And again, this will be up for sale soon via Paul's channels, wherever they may be. It will have, can't remember where I've put it, but it's here somewhere. The modulator, not the modulator, the VIC2 can is here. And once I've screwed this back in place, well, I've already cleaned up this, but I'll give it an extra polish. Clean off the thermal grease off of this and put some fresh on and put it away. I think we're done with this one. I don't think there's anything left to do. This is, as I said before, number 2 of the 5. I'm working my way up to the revision A very rare board with the very early serial number. That one is going to be a bit more of a challenge. There's one more to do with leaking caps. This one fortunately didn't have any other leaking caps. The last one had all leaking caps, and I've never seen in a C64 before. Even the ones, I spotted a few outside, but even the ones that are over here were all leaking. These ones that are in here weren't leaking too bad.